Hello, welcome to section 5.2. In this video we'll cover checkpoint 5.7. They want us to consider the region in the first quadrant between the two functions y is equal to 2x and y is equal to x squared. And then they want us to describe the region first as a type 1 region and then as a type 2 region. So it would be really good to be able to draw this out. And if we draw this out, we have y is equal to 2x. It's basically a line with slope 2, and then the parabola y is equal to x squared. And this is the region that we're talking about inside. That's probably not drawn to scale, but what is important, especially when you don't draw it to scale, what is important is to figure out the intersection between these two graphs. Clearly they intersect here at the origin, but I would be curious to figure out where else outside of the origin they intersect. And we can set them equal to each other, and we'll see that I think x is going to be 2. And when x is 2, we can put that both into the y into the functions, and you get 2 squared is 4, or 2 times 2 is 4. So we know that the y value is going to be equal to 4. Okay, now that we know these two pieces of information, we can work on trying to integrate with respect to y first. So as a type 1 region, let's make a note here. Type 1 region. This is saying that we're going to integrate with respect to y first, and then with respect to x last. And so a couple of things that I'm trying to make a note of is that the outer limits, or the last limits that we're going to integrate, are always going to be constants. And depending on if this is a rectangle, then all the limits will be constants. But if it's not a rectangular region, then your first, or your inside limits, would be functions. At least one of them would be a function, and then regardless of what happens up in the first limits, your last limits are always going to be constants. So the idea in a type 1 region, if you're integrating with respect to y first, is to draw a line perpendicular or parallel to the y-axis. And as you go parallel to the y-axis, you would ask yourself what function you're going to enter in first, and what function, while you're inside of the region, what function are you going to hit to get out of the region. So the function you're going to enter in first is going to be a y function. Y is equal to x squared. So that's going to be your lower limit, x squared. And then you're going to be inside of the region until you hit another function that gets you out of the region. And again, it's a y equals 2 function. Y is equal to 2x. Okay. Now, regardless of what's happening with your inner integral, your outer integral is going to be a y value. And so you just look at the constant y value starting point and the constant value exiting point, or final point. So that's just going to be a 2. So this is your type 1 region as a system of inequalities. Now, if you were going to write this as an integral, this would be a double integral of whatever function that you're dealing with, f of x, y we'll call it. And then this is going to be a dy, because you're integrating with respect to y first, and the y goes from x squared to 2x. And then your dx, your x limits are going to go from 0 to 2. All right. So that's going to be the type 1 region. Now let's reconsider the same area, the same region R that we're looking at. Again, we have limits. We have the intersection at x is equal to 2 and y is equal to 4. And again, this is y is equal to 2x, and y is equal to x squared. All right, now if we're going to treat this as a type 2 region, the type 2 region says that we want to integrate this with respect to x first, and then with respect to y. Now the y are going to be, the limits for y are going to be constants, so that's the outer limits, and so we want to know what the limits are for the x. And to do this, you want to draw a line parallel to the x-axis, and you want to ask yourself, what function are you going to go into to get into the region, and what function do you need to hit to get out of the region? Now these are x values, so you're going to hit this function first, or this graph first, but you want that as an x value, or in terms of y. So if you solve for x, this is going to be a 1/2 y, and that is going to be the function, the x value function that you're going to need to get into the region. So this will be your lower limit. So this is going to be 1/2, well, let's just call it a y over 2. So that's a y over 2. And then you'll be inside of the region until you hit this function over here. Again, you want this in terms of x. And so this is going to be x equal to square root of y. Now normally we would look at the plus and minus square root of y, but we know that this is on the positive side, so this is going to be the positive y. So this is going to be the square root of y as your upper limit for the x values. The y values, again, will be constant limits going from 0 to 4. And so if you were to set up this double integral of whatever function that you're dealing with, you're going to integrate with respect to x first. So this is going to be dx, and this is going to have our lower limit of y over 2 and an upper limit of y square root. Square root of y. And then let's be careful with the way we write this. Okay, and then the y, dy, goes from 0 to 4. Constant limits on the outside. Okay, so this is the type 2 region, and this is the type 2 resulting integral. All right, I do want to make a big point to say that however we set up our integral, type 1 or type 2, the outer limits always have to be constants. Outer limits are constants. Okay, all right, so I hope this helps.